Anytime Maritime.
Anytime Maritime.
Good morning, Anytime Maritime, and welcome to another episode. Today we will be letting you in the Korea Maritime Week conference that recently happened. That was exactly on October 22nd at Seoul, Korea, and we attended there. And their industry leaders gathered to address how the critical maritime industry transitions, digitalization, and decarbonization are being operationalized in the realm of small and medium-sized vessels. The forum underscored that while vessels may not sail under SOLAS regimes, they face the same imperatives of safety, sustainability, and efficiency. So, as Anytime Maritime and as chairperson of FastCat, I was there. I delivered a presentation sharing about our involvement in Interferry, a global organization of ferry owners and stakeholders of the world. And there we shared about the international cooperation and partnerships that is being done to promote safety and everything about the ferry business. And also I talked about FastCat and what we do in decarbonization, in digitalization, so that other operators may learn from our experience as well. I was particularly gratified to see how technology and regulatory pathways discussed there is now advanced in other countries. And definitely we have something to learn, and we are bringing it home here in our country. And so as we share the conference proceedings recorded, sent by the Korea Maritime Safety Agency, we would like to thank them for sharing this recording. We would like to thank them for hosting us. It's so gratifying to be part of it and to be hosted. Alam niyo po, Korea, hinost nila, pinadalan ng ticket at libre pa hotel. Buong conference, and we were really treated very well. So, Komsa, thank you very much. Kamsahamnida, Korea. And we saw a lot of our stakeholders from Marina, and of course, mga global leaders, IMO heads, ICS, they were there, all gathered in Korea and hosted by Korea. And definitely, when we gathered together, when all maritime leaders gathered together, there is just that clarity of the future of the maritime industry. So, please, listen, watch, learn, and I hope that you bring in a thing or two, and that you will see that the maritime industry is in good hands if we sail safely together. So, people, Anytime Maritime!
Get started. The Small and Medium Ship Safety Forum will begin soon, so I kindly ask all participants to please be seated. We will now begin the opening ceremony of the Small and Medium Ship Safety Forum. Today's ceremony will commence with opening remarks followed by congratulatory addresses and a commemorative photo session. Good morning, ladies and gentlemen, and welcome to the Small and Medium Ship Safety Forum. My name is Myung Se-eun, and it is my greatest honor to serve as an announcer of today's meaningful event. It is a great pleasure to meet you all, and I sincerely thank everyone for taking the time to join us despite your busy schedules. This event will center on the two key global trends driving the international maritime sector, digitalization and decarbonization, collectively referred to as 2D. It will serve as a venue to share major countries' cases and jointly explore practical solutions to the safety and environmental challenges faced by these vessels. Today's forum brings together experts from both Korea and abroad who will share their valuable experience and knowledge. They include representatives from the Korea Maritime Transportation Safety Authority, KOMSA, Interferry, the University of the Basque Country, Spain, and the Danish Institute of Fire and Security Technology, the Norwegian Maritime Authority, and the Korea Research Institute of Ships and Ocean Engineering, KRISO. You can also participate in this forum through YouTube live streaming. During the live streaming, you will see 3 QR codes on the screen. One for downloading the program booklet, another for the satisfaction survey, and the other for submitting questions to each speaker. For those joining us on site, the same QR codes are available on the posters placed at your seats. We kindly ask for your active participation in both survey and Q&A submission. And we have also prepared souvenir for those who have submitted their satisfaction survey. And once you finish the survey, please present the screenshot to the registration desk so they claim your souvenir. Finally, please note that simultaneous interpretation is available for on-site participants. Channel 1 is for Korean and Channel 2 for English. Now then, let's begin the Small and Medium Ship Safety Forum. Before we begin the opening remarks, I would like to first introduce our distinguished guests who are with us today. Please welcome Mr. Dong-geun Lee, Executive Director of Maritime Transportation Division at KOMSA. Ms. Dorian T. Kabua, Deputy Chief of Mission from the Embassy of the Republic of the Marshall Islands in Korea. Mr. Bahati Lucas Masila, Minister Plenipotentiary from the Embassy of the United Republic of Tanzania in Korea. Mr. Chol Hong Kim, Commissioner of the Incheon Regional Maritime Safety Tribunal. Mr. Kyu-sun Choi, Executive Director of Strategic Business Division at Korea Institute of ACE-2 Navigation. And next, please welcome Mr. Sang-uk Kim, Director of Management Innovation Division at the Research Institute of Medium and Small Shipbuilding. We are also joined by 4 speakers from Denmark, Norway, Philippines, and Spain, as well as 12 senior officers from the Maritime Administration of 6 Southeast Asian countries who are visiting Seoul under the IMO Integrated Technical Cooperation Program. Due to time constraints, I regret that I cannot introduce each of you individually, but please know that we are deeply honored by your presence. Thank you. That concludes the introduction of distinguished guests for the 4th Small and Medium Ship Safety Forum. Now, I am pleased to invite Mr. Dong-geun Lee, Executive Director of Maritime Transportation Division from KOMSA, who will deliver his opening remarks. Please welcome him with a warm round of applause.
존경하는 내 기빈 여러분 그리고 참석자 여러분 안녕하십니까. 해양교통안전공단 해양교통본부장 이동건입니다. 다시 한번 인사드리겠습니다. 올해로 4번째를 맞이하는 중소선박 안전기술 포럼을 개최하게 되어 뜻깊게 생각하며 이 자리에 함께해 주신 모든 분들을 진심으로 환영합니다. 우선 바쁘신 와중에도 이 자리에 함께해 주신 우리 해양수산부의 심성철 과장님 정말 감사드립니다. 그리고 인천의 해양안전심판은 그리고 주할 마샬 제도 대사관 그리고 탄자니아 대사관 아마 조금 늦게 오시는가 봐요. 그리고 노르웨이 회사청 인터페리 그리고 스페인 바스크 대학에서 오신 분들도 환영합니다. 그리고 덴마크 화재보안연구소 또 각국의 주관청 연수생 분들을 비롯한 모든 참석자 여러분께 깊은 감사의 말씀을 드립니다. 이번 제4회 중소선박 안전기술 포럼은 국제회사 기술협력 사업의 일환으로 해양수산부와 그리고 IMO의 지원 아래 한국해양교통안전공단이 주관하여 마련된 자리입니다. 중소선박 안전기술 포럼은 IMO 회원국 간 협력 강화를 통해 해양 안전과 환경 보호 역량을 높이고 특히 각국의 연안 중소형 선박에 대한 안전기술 발전과 지속 가능한 운항 환경 조성을 목표로 하고 있습니다. 우리나라를 비롯한 여러 동상의 국가에서 발생하는 해양 사고의 다수는 연안 중소형 선박에서 발생하고 있으며 구조적인 제약 그리고 장비의 노후화 그리고 선원의 고령화 기상변화 대응의 한계 등 복합적인 요인이 작용하고 있습니다. 이러한 연안 중소형 선박의 위기를 극복하기 위하여 이제는 대형선 중심의 기존 안전 논의에서 한 걸음 더 나아가 연안 중소형 선박의 현실을 반영하면서도 디지털화와 그리고 탈탄소화 흐름 속에서 새로운 정책적, 기술적 해법을 모색하는 것이 매우 중요합니다. 올해는 바로 그 두 가지 축, 디지털화와 탈탄소화를 중심으로 각국의 정책과 기술 적용 사례를 공유하고 중소형 선박의 안전성과 지속성을 높이기 위한 협력 방안을 논의하겠습니다. 또한 오늘 포럼에서 각국의 연안 중소형 선박 안전관리 정책과 기술 경험을 서로 공유하고 현장에서 실질적으로 적용 가능한 지속 가능한 해법을 모색하는 협력의 장이 되기를 기대합니다. 그리고 이번 논의가 IMO 기술협력 사업의 성과로 이어져 회원국 간의 포용적이고 균형 잡힌 해사 안전 발전에 기여할 수 있기를 기원합니다. 한국해양교통안전공단은 앞으로도 IMO, WMU 등 각국의 해사기관 및 학계 등과 협력하여 모든 선박이 안전하게 항해하는 바다 그리고 사람 중심의 지속 가능한 해양 안전 체계를 실현하기 위해 최선을 다하도록 하겠습니다. 끝으로 이번 포럼을 위해 헌신해 주신 우리 해양수산부 그리고 IMO 관계자 그리고 모든 참석자 여러분의 노고에 깊이 감사를 드립니다. 여러분의 건강과 행운 그리고 소속 기관의 발전을 진심으로 기원드립니다. 오늘 이 자리에 함께해 주신 모든 분들을 다시 한번 진심으로 환영합니다. 감사합니다.
Thank you very much, Director Lee, for insightful remarks. And next, to celebrate the success of this forum, Professor Massimo Q. Mejia, President of the World Maritime University, and Ms. Dorian T. Kabua, Deputy Chief of Mission at the Embassy of the Republic of the Marshall Islands in Korea, kindly prepared congratulatory remarks. First, we will hear congratulatory remarks from Ms. Kabua. Please welcome her with a big round of applause.
안녕하세요, 여러분. 반갑습니다. Distinguished guests, ladies and gentlemen. On behalf of the Republic of the Marshall Islands, it is my honor to extend congratulations to the organizers and participants of the Small and Medium Ship Safety Forum, held as part of Korea's Maritime Week 2025. This gathering represents an important step forward in our shared mission to strengthen the safety, sustainability, and resilience of small and medium-sized vessels, particularly domestic ferries and fishing vessels that serve as lifelines for so many of our coastal and island communities. These vessels connect our people, they support our economies, and sustain our way of life across the Pacific. Yet despite their vital role, they continue to account for a disproportionate share of maritime incidents and fatalities. Forums such as this are therefore essential to advancing practical solutions that save lives, reinforce the foundations of maritime safety. The Republic of the Marshall Islands recognizes the great value of this forum as a platform for experts and officials to exchange knowledge, share innovations, and explore new avenues for cooperation. The focus on digitalization and decarbonization technologies, often seen as the domain of larger ocean-going ships, demonstrates how innovation can and must be adapted to meet the needs of smaller domestic vessels. This reflects the aspirational direction of progress we all seek, a maritime sector that is both safe and sustainable for all. For the Marshall Islands, and indeed for many other Pacific Island countries, today's discussions resonate deeply. The work being showcased here aligns closely with the mission of the Micronesian Center for Sustainable Transport, which strives to promote low-carbon, resilient, and inclusive maritime transport across our region. Likewise, it complements the IMO's Pacific Forum on Domestic Ferry Safety, reaffirming our shared commitment to strengthening domestic vessel safety through collaboration, capacity building, and technological innovations. We commend the Government of the Republic of Korea, the International Maritime Organization, and the Korea Maritime Transportation Safety Authority, KOMSA, for hosting this timely and impactful event. The Republic of the Marshall Islands stands ready to continue working hand in hand with our partners to advance maritime safety and sustainability, not only within our own waters, but across the Pacific and beyond. 고맙다, 감사합니다, and congratulations once again on this successful forum.
We sincerely appreciate Ms. Kabua for your great congratulatory remarks. Next, we will watch a congratulatory video message from Professor Mejia.
Greetings from the World Maritime University here in Malmö, Sweden, and it is my great pleasure to join you virtually for the fourth session of the Small and Medium Ship Safety Forum. I warmly congratulate KOMSA for hosting this important gathering, which provides a platform for experts to exchange policy and technological insights to enhance the safety of small and medium-sized vessels. These vessels, such as passenger ships and fishing vessels, play a pivotal role in the lives of coastal communities and in bringing societies together. Ensuring their safety, therefore, strongly aligns with the aims of the International Maritime Organization, our parent institution. Recognizing this importance, the World Maritime University has long pursued education and research dedicated to the safety of passenger ships and fishing vessels. Our projects, including statistical analyses of passenger ship casualties, demonstrate our commitment. Several of these outcomes have been submitted as agenda documents to the IMO, sharing valuable insights with the wider maritime community. WMU and KOMSA recently strengthened our collaboration through a Memorandum of Understanding signed on 18 March, focusing on the safe and sustainable operation of domestic vessels and the promotion of digital ship technology. We look forward to broadening this cooperation through joint research and related initiatives. In this context, this year's forum theme, Digitalization and Decarbonization, offers potential breakthroughs to unlock safer and more sustainable navigation of domestic vessels and to bridge the gap between these vessels and international maritime trends. Organized under the auspices of the International Maritime Organization and the government of the Republic of Korea as part of IMO's Integrated Technical Cooperation Program, this forum also supports member states in strengthening their maritime safety capacities. I wish the forum every success and trust it will provide meaningful and practical insights for all participants, including the invited officials from the maritime administrations of 6 ASEAN member states. Once again, congratulations to COMSA on the opening of this 4th session of the Small and Medium Ship Safety Forum. May the discussions here inspire further cooperation and tangible progress towards safer seas. Thank you.
Our sincere thanks to Professor Mejia for this wonderful message. Lastly, before we begin the main session, we would like to take a commemorative photo shoot with our distinguished guest of this forum. Distinguished guest, please come up to the stage for a group photo. Thank you. This concludes the opening ceremony of the Small and Medium Ship Safety Forum. We will now begin the session 1. Please take your seats. In this session, we will explore the theme digitalization, from data-driven decisions to smart safety measures. 3 speakers from both home and abroad will deliver their presentations, followed by a discussion on future cooperation. Before the discussion, we will also have a Q&A session after the presentations. If you have any questions during the presentations, please submit them using the provided QR code. Or if you are here on site, please feel free to ask your questions during the Q&A session. To begin the session 1, we will hear from Ms. Mary Ann Pastrana, board member of Interferry and chairperson of Archipelago Philippines Ferries Corporation. She will deliver a presentation on the topic, Interferry and FastCat, a journey to sustainable ferry operations. Please give her a warm round of applause.
Good morning. Distinguished colleagues, maritime leaders, and fellow champions of ferry safety. I am honored to join you today, home to some of the world's finest shipbuilders and maritime minds. As both a proud member of Interferry and chairperson of FastCat, a ferry operator from the Philippines. Today, I bring with me the voice of 7,641 islands. I bring stories from communities where ferries are not a luxury, but a lifeline. I bring a journey not just of vessels, but of vision, vulnerability, and ultimately victory. This is our shared journey to sustainable ferry operations. Let me start with Interferry, our global voice for ferry safety and sustainability. With over 270 members in 40 countries, Interferry serves as a vital bridge between ferry operators, regulators like IMO and ILO, and innovators across the value chain. We champion standardization of safety practices across diverse operating environments, advocacy for regulatory frameworks that are grounded in realities, support for domestic operators, especially in developing nations, and technology adoption that is both practical and cost-effective. As an Interferry board member, we don't just represent companies. We represent commitments to life, livelihood, and legacy. But we also recognize the hard truths. From 2011 to 2021, countries like the Philippines, Bangladesh, Indonesia, Congo, and Nigeria accounted for majority of ferry accidents globally. In my own country, the Philippines, we accounted for 7% of all reported incidents, mostly from capsizing and sinking. Yes, the trend in our country has slightly improved, but let's be honest, slight is not good enough when lives are at stake. The risks we face are multidimensional. Operational errors such as poor lookout or vessel modifications, technological gaps like outdated navigational aids or lack of redundancy, human factors from overloading to poor training, policy limitations due to fragmented oversight, and economic pressures where the cheapest option often becomes the default, even when it's dangerous. These are not just technical problems, they are cultural, structural, and deeply human challenges. At Interferry, our response is systemic and strategic. We launched the Ferry Safe Project, with country-level assessments and policy recommendations. This was held in the Philippines and recently in Africa, in two sides of Africa, in Tanzania and in Nigeria. We developed best practice safety standards and training guides. We built platforms for knowledge exchange like the one we're part of today. And we continue to promote affordable digital tools, empowering even small operators to level up their safety management. We don't just react to disasters, we prepare to prevent them. Digitalization has become the turning point. We've moved from paper logs and manual checklists to real-time alerts, predictive analytics, and integrated dashboards. It's not just about tech for tech's sake. It's about seeing a storm before it hits. It's about knowing when a part is about to fail. It's about making decisions based on data, not guesswork. This is how we save lives. Allow me now to zoom in the Philippines, my home, and the birthplace of FastCat. We are an archipelago of 7,641 islands struck by typhoons, about 28 in a year. We just had one, and there's one arriving. I saw today in the report from my office. Our country is served by 12,000 domestic passenger vessels, many of which are old and non-compliant. In these high-risk waters, FastCat chose a different path. We didn't wait for the crisis. We invested in solutions proactively, systematically, and sustainably. Over the last 12 years, FastCat has committed to safety as a way of life. We deployed catamarans built to international class standards. We engaged with partners and worked with the stakeholders like Marina, the Philippine Coast Guard. We advocate for women in maritime, World Ferry safety, and Interferry itself. We contributed to the Ferry Safe project, offering insights from the front line. We standardized STW aligned training, ensuring crew competence, and most importantly, we embraced continuous learning. Because safety is not an event, it is a habit. This is a slide that is a result of the Safe Mode research, EU-funded research, which FastCat is a part of. And I always like to share this because this is what we are adopting. It's called the Safety Learning Cycle, wherein what is being taught is how do we capture our data or data capture? Do we analyze the data, or what are we doing to analyze the data? What did we learn from our data or the safety learnings from the data? Did we have deep learning? Did we have a risk-informed design? And the cycle goes on in our operations and maintenance. And this is how we got to our safety learning culture. And this is what we are pushing for now. So, in having safety as a culture, the safety is not only in the design of the ship. You can see on screen one FastCat, that I think that's FastCat M19. So we considered the design of the ships, and it is a catamaran, lightweight, with aluminum. And again, as I mentioned, we value partnerships. We're involved in very safe projects, not only locally, but globally as well. We have standardized crew training, and we share our knowledge to forums such as this. We have digitized our operations through Vessel Tracker. This is a German technology that we use. ISTO for cargo stability, which is an Indonesian technology. We have digitized our online booking systems for customer experience. We have also used AI by our use of our national sales automation and preventive maintenance systems, and also used it for safety audits and maintenance. Each of these tools on their own are powerful, but together they form an ecosystem of safety. We operate 18 vessels across 8 routes, and we are happy to say that not a single life lost since we began. And we didn't stop with safety. We aligned our innovations with environmental performance. Our topic today would be decarbonization, and we have happily started our decarbonization journey using this carbonization strategies operationally, such as the use of Jotun paints or anti-fouling paints, and working with their research and development department, testing decarb technologies or air lubrication, adopting Hullbot or robots in cleaning our hulls or autonomous cleaners, installing solar panels and wind turbines to power our bridge, because in today's world, safety and sustainability must sail together. But let me emphasize, digital tools must not operate in silos. When systems are fragmented, we lose insight. When data doesn't follow, people fall through the cracks. At FastCat, we built a unified dashboard where operations, safety, environment, and customer data all connect. This is the future. One view, one system, one culture of care. Our investments also support the IMO decarbonization targets. With the same systems, we track emissions, optimize routes, and reduce fuel consumption. We have just started and we have piloted this, and results can be shared over time. But what we want to say is that we don't have to choose between saving lives and saving the planet. We can and we must do both. As a close, I want to leave you with this thought. Safety is not built on policies alone, but by people who care enough to protect each other. Every safe arrival is a silent victory. Every ferry that crosses the sea safely connects not just ports, but families, communities, and futures. Let's keep working, not just for compliance, but for compassion. Let's advance together. Safety, innovation, connectivity. Let's build ferries that float, yes, but more importantly, let's build trust that lasts. From Interferry to FastCat, and from the Philippines to Korea, let's bridge the seas together. Thank you for your time, your commitment, and your courage. Mabuhay, kamsahamnida, and we will all sail safe.
Thank you, Ms. Pastrana, for your insightful presentation. Our next speaker is Professor Zigor Uriondo, Associate Professor at the University of the Basque Country, Spain. He will deliver a presentation on condition-based maintenance in marine propulsion systems, use case-safer and more efficient fishing operations. Please welcome him with a warm round of applause.
Okay. Hello, good morning. I will start my presentation regarding condition-based maintenance. Okay. First, this is the index I will follow. Initially, I will start with context of application regarding mainly the fishing ships, and then I will follow with the rest of presentation. When we talk about fishing ships, I mean, the main layout that we can find in the propulsion system will be a main engine with a gearbox, shaft, and the propeller. Sometimes, or many times, will be a controllable pitch propeller, a CPP, but many times will be just fixed pitch propeller. Other cases, the auxiliary generators will be engines driving the diesel generator. And on board, we can have other auxiliaries like could be hydraulic pumps, etc., driven by electric motors or, again, other type of propulsion. Regarding something, we can have a diesel electric, but it's not so common. Regarding fuel, we can say that diesel is the standard. In some cases, we can have heavy fuel oil. And installed power could be from just some kilowatts to thousands of kilowatts, sail distance daily to weeks or even months, and from technology, from very simple to very complicated. So we are going to have a very heterogeneous layout on board. Okay? When we look at how mainly the engines and the vessels also are maintained, many times, especially with the smaller ones, what we are going to find is that they are not maintained, especially small engines. Maybe they could even not be repaired in whole life and just be replaced by a new one when they have accumulated thousands of hours. So if a failure is detected and they can wait, they will wait. Okay. Sometimes we'll be based in economical situations. The incomes are completely unsteady and depend fish prices, how much the catches, etc., etc. Also seasonal maintenance. So when they are not fishing, they will make maintenance. And in some cases, we are going to find that they follow strictly the maker's manual, that it's a safe way, maybe not the more efficient economically, but it's a safe way. So this means that in many cases, we are playing with risk. So if we want to improve, there are options. One of the one that here I come to propose is just make better operation with condition-based maintenance. Okay, this is not really opposing, especially the maker's recommendation. This is in order to implement, to complement the maker's recommendation and follow what they say in order to do it. For this, we consider that the monitoring and digitalization is completely necessary to, it's a must if this has to be implemented. Well, when we go to monitoring usual fishing vessels or the engines that we can have on board, we can have very simple, the basic systems that could be from simple thermometers to pressure dial gauges, that they are not bad, but here we can have a strong human bias, because there maybe probably we are going to see someone 74 degrees, another one 76, another one 75. Okay, it's not bad, but if we want to follow a good trend and to make a model, maybe it's not the best. Other options, more modern options, could be digital monitoring systems that we are going to use electronic sensors like thermocouples, pressure sensors, etc. And the good thing that these systems can provide is the possibility of transmitting the data. So this data from these systems can be transmitted and integrated on board with several different systems. Okay, this will make data sets that later can be transmitted on board, can be recorded for historical data, and also will eliminate in many places this human bias in the time of looking at different sensors. Well, this is something that I consider, if we want to implement a condition-based maintenance, digitalization is a must. So we need it. Otherwise, we are not going to be able to assess a real condition. What we can find many times now, okay, handwritten data that are sent to the expert engineer onshore, and later this is compared with testbench data. Okay, basically we can call it an offline data monitoring by a source specialist. Well, drawbacks that this. Well, okay, the problem is that many times the data that we have from the factory were recorded in conditions that they are not repeatable on board. We are not going to have the same conditions in factory, in the test bench, and on board. So this will change many of the parameters when you compare with one from the other. This is not going to let us to follow a historical trend and see how the engines are changing. We are talking about that basic or strong maintenance is an issue of years, 2-3 years, 20,000 running hours. And in this case also we can find that also the design is not exactly according to what was in the test bench. Here comes that recording data digitally can help because we are going to follow a history of the vessel and we can see how the values have changed. Well, as I said, main drawbacks of following or just looking at manual taking data that are later sent short to replace them. Initially a delay. We are going to have a delay because data have to be written down, sent to the office, then someone in the office has to check this data, make an evaluation and reply. This can take days, weeks even, many times. Also, as I mentioned, human bias is the same people, is the same person, the one that is taking always the same data, or is changing. Or maybe that sometimes, and I have seen experience many times, the data are just written down somewhere that is not in the engine room. Values differ from the test bench. This means that it's really complicated to detect trends. So it's very complicated to see how a metric is changing with time if the values are taken like this. And at the end, always an expert evaluator is required, which means a delay in the data evaluation. So many times when deviation is detected, it is already too late. It is already too late. And if it is too late, then we are hindering safety on board. I am talking about the propulsion system, but if we have no propulsion, the vessel cannot move. So at the end, this safety is extended to the whole vessel. Well, as I mentioned, deviation is detected too late. What does that mean? In common situations, the problems will accelerate. So if some metric is increasing, let's say if one cylinder is suffering a fault, the problem will accelerate probably. It will become very fast. Maybe we cannot wait weeks or a month to have a reply. A small repair work, stopping on time, making some small adjustment could make big savings economically, but also in safety. This also means not playing long downtimes. Nowadays, stocks of spare parts are a problem, are being reduced. So if we are suffering a big failure, we can be stopped for long. And of course, if we lose propulsion, human life problem is on board. So we can see that monitoring can save. There are some vessels that, not small ones, I am talking about fishing vessels that can have complex ECR control rooms with many systems on board and good monitoring. This is an engine control of a fishing vessel, but still, we still have that people on board, they are fishermen. So their main target is fishing. So sometimes they are not able to take care of machinery properly or as good as they would like, because they are very busy with other things. And just we can have people looking at sometimes data are not properly monitored. Okay, then we want to improve. We want a continuous evaluation of performance on board. And for this, the first thing that we need to know is what is a good condition of an engine. For this is where historical data can play a very important role. If we have recorded when the engine was new and how the engine was running, we have a signature of the engine, we have a picture of the engine in good condition, this could be compared. That's why digitalization is needed for a condition-based maintenance strategy. Challenge with this, first, monitoring system cost. We are talking about small fishing vessels. The monitoring system cost can be a very important part of the engine. A 6-cylinder small engine, I don't know, 60,000 euro. Monitoring system, 6,000 euro, 10%. Okay, 6-cylinder engine, same quantity of cylinders, same quantity of pressure sensors, but it is a big engine. Maybe the monitoring cost is just a 2%, 1% of the engine cost. So reducing cost and selecting properly the metrics is important. And then development the intelligent systems. We can make this picture of the engine, this signature of the engine, but who or what is going to decide that the engine is not as it was in the beginning? When it is a problem or it's just a small deviation that is not a real problem? This is maybe the biggest challenge, and still there is much work to do. For monitoring, cost optimization strategic, not monitor whole engine or select what to monitor. The people that we come from academia, we like to monitor and measure everything, but we must think that we are on board with systems that have limited costs. You can see this is an example of a high-end combustion measuring system that is fantastic, but just one sensor, the cost might be around 1,000 euro. And in a small engine, it's not possible to implement. So we must consider what we can do on board, not what we want to do. What can be done on board and what can be implemented. Okay, so just making a small summary. In the traditional system, we have engine, data are collected on board. If we exceed the value from an alarm threshold, we don't exceed, we don't make anything. If something happens, there is an alarm, we stop and we solve. What we propose is this data are stored. We develop a model, and this model later will run 24/7, controlling which are the data on board. And if there is no deviation, okay, we can run. And if something is occurring, if there is a deviation that we cannot call it as a normal deviation, okay, let's analyze, let's think what can be planned, what can be the next step. This has to be combined with the rest of traditional systems. So we cannot forget a visual inspection in the engine room. If a leakage occurs, something is happening, and a sensor maybe is not going to tell us easily what is happening. Vibration measuring system, follow with the lubrication on oil analysis. The traditional system are there. So the target is not to replace people on board or systems that we have been using on board, is to complement, okay? Is to complement what we have. And for this, we have to develop models. Regarding engine modeling, just very briefly, we can have thermodynamic models, that the first one use thermodynamic laws. If we can validate with this one with experimental data, it will be even more accurate. We can have commercial softwares that can do this with work. It's not easy, okay? But and this we can have it. Problem and drawbacks. First, detailed heat geometry of the engines in many times is not available. This is maker's information. We need the detailed inputs. The measurements have to be very good. Maybe on board they are not good enough. And computing time. Maybe one cylinder simulation can take days. So basically, they are very useful for research, but cannot be implemented on board. We should think another way to do it. Then we have data-driven models. So basically, we are talking about machine learning. And we talk about learn, we mean that we need historical data for that. Okay? So we are going to record historical data, could be locally or in cloud system, and with this we are going to develop a model. So again, monitoring and data storage are completely necessary. Regarding models, not going deep there, just mentioning them. The first one, the supervised learning, we have already faults. This is commonly used, especially in vibration machinery or rotation machinery, gearbox or pumps or whatever in bearings. They are even commercial systems, they are very good. And the other ones is that the unsupervised and semi-supervised learning, that we don't have faults. So for this, what we do is we model the engine in good condition because of the data that we have, the engine in good condition, and in this way, when we deviate for this good condition, we give an alarm. Okay, which are the best methods or which are the best models to do it? It's an iterative process. Sometimes we have to test with data and select which are the best ones. So it requires work onshore, okay, and to make different evaluations. So then what we are going to have is the engine data, we store it, we cure the data, we develop a model, we evaluate it, and after evaluation, if the result is not good, we have to make it again. If the model is good, we implement it. Implementing means that we are going to obtain at the end, to make an idea, some coefficients, some values that later can be implemented in a simple system that could run on board. Okay, that could run on board. This is an offline process. It's time-consuming, but nowadays even personal computers could be used for this, so it's not necessarily big machines for this. There we have an example in different steps. This is a project done some years ago. Okay, the first step is that we keep data. It goes run for 2 years, more than 10,000 running hours. Then we cure the data, we select the data, and in the step 3, we make the model. And the final step, the last step, is that when we implement in a commercial software that it's LabVIEW, there we implement it and we keep it running on board in parallel with the monitoring system that is recording data. So target is we monitor data, we develop the model, we obtain data with the model, we compare them, and then if there is deviation, we inform the crew on board, or even we can send a trip, send a signal to the people on shore. In our experience, artificial ANN, artificial neural networks, are a good tool for this. There we have an example of a value in a test bench where with some inputs that are monitored, we can obtain several outputs that are regarding the engine performance. This is for test bench. So I mean, we are monitoring also emissions, several things. So this is just first step that we can later implement on board. And for implementing on board, we can reduce the number of inputs. For this, we need reliable data. So we have to select values that are measured constantly on board and will be measured constantly on board. Speed, torque could be also via the fuel oil rack or fuel oil index, or fuel oil consumption, that could be again also via fuel oil rack or fuel oil meters. Depending on the type of engine, they could change the data we need. If it is a main engine, probably a speed will be necessary. If a speed is changing, I mean, with a FPP, fuel oil rack or fuel oil index, propeller pitch, if it is a controllable pitch propeller, and then if it's possible to install, and it's possible to install maybe regarding money, a torque meter or a failure meter. In a diesel generator, speed is not a variable. It's not changing. Always constant speed. So then failure index or another value like charge or pressure. This will let us develop different, smaller models. Why? Some values should not change too much when some metrics should not change too much when engine is in operation because they are to be kept constant. Fuel oil pressure, lube oil pressure, cooling water temperature, etc. They have thermostatic valve or pressure regulating valves. So they are quite steady and could be a distribution could be found that will tell us that more or less when we are close to the value that we should have. Smaller models could be developed depending on the subsystems in the engine, okay? Like we can have for the cylinder liner temperature or the iron exhaust there that is a gas temperature in the engine. Values could be very accurate. Here we have values that we are the mean absolute error that it's below 2%. 2% except one of them in one whole year. So the models developed could be quite accurate. This is not exactly the problem or the difficulty. The difficulty comes because the model could become quite, let's say, steady in the values, okay, the dashed lines, but the actual one might differ in a daily basis, and it's not a problem. That's why trend and following trends is important. If we start deviating too much from the model, then there we are a problem starting, okay? Below we can see that two variables and you will not see the difference because the model is predicting it perfectly. So the difficult thing here is to define the criteria of when it is going to occur a fault. We are not talking about of an alarm level. No, alarm, there are already systems that are going to trip an alarm. We want something that is going to tell us before the alarms occur. Okay, and this is the difficulty, to define when this happens. Here we can see in 1 year, okay, one whole year, how many times one variable has gone out of the threshold. Okay, the next step is to define if this quantity is a problem or is not a problem. Okay, let's see it clearer with values that should be kept quite constant. Here we can see that between these two lines is within threshold, but sometimes some values there, they are just in the limit. Okay, but just once, next day system went bad. Something happened on board, we don't know what, that went out to threshold, but it's not a real problem yet, okay? So expert evaluation is needed. To go in finishing, the models are not for always. If a repair work is carried out, the model can have some slight differences. And there we can see 2 years, 2020, 2021. Here we have 11,000 hours data, and the model is quite well, but from 1 year to the other, probably a refreshment of the model is needed. To finish, okay, there we have the engine. We have to monitor the engine. Then we make several subsystems. This is sent to server on shore. Okay, there we develop the model with different databases. You can see 2 years, 11,000 hours. So it's quite. Then we have the model. And we characterize the thresholds to define when we are going to start having a problem. And after this, the expert evaluation is needed. The question is that the expert does not need to be looking at the screen 24/7. There is, let's say, a trained engineer, not an expert, but a trained engineer developing 24/7, that is the artificial intelligence. Finish. Historical data are needed, so monitoring and digitalization is a must. Okay, this will reduce operational cost, will increase safety, and also we still need human intervention to define the thresholds, and if the deviation is too big, to inform what is happening on board. And that's all from my side. Okay.
It was a great time to learn about the various information of propulsion systems and models. We sincerely thank to Professor Uriondo for your excellent presentation. Our third speaker is Dr. Yuna No, head of the Digital Convergence team at KOMSA. She will deliver a presentation on data-driven approaches to maritime safety management. Please give her a warm round of applause.
Hello, everyone. Thank you for having me here today. And my name is Yuna No, and I'm the team leader of Digital Conversions team at KOMSA. And today I'm going to share some actual practices on database approaches to maritime safety management and how we are applying AI technologies in this field, which is a hot issue these days. So the presentation will proceed in this order. And let me briefly introduce about KOMSA and the efforts that we are applying for the digitalization. So as many of you may know, KOMSA was re-established in 2019, evolving from the Korea Ship Safety Technology Authority, and we are now the only organization in charge of comprehensive maritime traffic safety management under the Ministry of Oceans and Fisheries. And our mission is very simple and clear. To secure maritime safety through accident prevention as well as operation and management of maritime transportation. And to achieve this goal, we carry out many different businesses, from the traditional business ship survey and passenger ship safety management, and to safety culture promotion and R&Ds on eco-friendly and autonomous ships, international cooperation, and lastly, data-driven safety management. And our entire safety management framework is now data-centered, as you can see in the middle. It's a big data platform, and it's designed as a feedback loop. So the causes and outcomes of accidents are analyzed like this and reflect back into our safety management process. And now let me introduce a key case of database management. Since 2021, KOMSA has been building a big data platform for about 3 years, and we established an integrated big data platform that collects and analyzes a variety of data. And this platform doesn't just store data, it also performs a large-scale processing, including AI-powered analysis system right here, to turn raw data into useful information and public services. And currently, the platform connects about 30 systems from 10 different organizations in the maritime sector, including the Ministry of Oceans and Fisheries and Korea Coast Guards and etc. And we collect real-time vessel position data from various vessel position transmitters such as AIS, VPAS, LTM, and as well as information on accidents, and vessel specifications, ship surveys, and marine environments, including sea weather. And we analyze, visualize, and deliver this information as public service right here to as a public service through the Maritime Transportation Safety Information System. We call it MTIS. And now we provide services through both web and mobile app. So MTIS provides more than 20 services, and now let's take a closer look at some of the key services. This is infographic. So this infographic service provides visual summaries and charts of maritime accidents, so users can easily understand the overall safety status and trends. And this service shows various statistics on maritime accident. And this is not just a statistic, but an interactive tool that allows users to generate customized statistics based on different factors like vessel type, accident type, or month, or season, and etc. So it's designed to make analysis easy and flexible for everyone. And Maritime Accident Keyword Analysis service analyzes 14 years of accident reports and identifies key causal factors by accident type. So it visualizes the relationship between keywords in a network form, right here, in a network form, so helping users to see how one cause leads to another. And for example, in the case of capsizing accident, seawater may enter the vessel due to high waves and leading to a loss of stability. Or in other case, if cargo is not properly secured, a sudden turn may cause the cargo to shift, and which can also result in a loss of stability. So like this way, even when the outcome is the same, the causes and outcomes are, the sequences are different. So by understanding these sequences, we can find the chain that leads to accident so that we can break it and intervene before accident occurs. And this service visualizes accident hotspots on a map. We utilize hierarchical clustering. So as we zoom in, the size of cluster gets smaller, and we are able to see the specific locations of accidents. And it shows where certain types of accidents happen most frequently. For example, in road transportation, like cars, if there are frequent speeding accidents, then the installing speed camera would be effective. And for other cases, for areas with many pedestrian accidents, then the crosswalks would be the solution. So for the central and local governments, and their budget is always limited, this service helps them to implement the cost-effective prevention measures. And this service displays the current traffic situation in all Korean waters based on real-time position data. Around 100,000 vessels are registered nationwide, including 65,000 fishing vessels. Roughly 10,000 ships are sailing at any given time. So by analyzing vessel density, the system can calculate congestion levels and provide alerts for ships entering crowded area, so helping them navigate more safely. So now let me introduce PATIS, which is short for Passenger Ship Transportation Information Service. In Korea, every year, around 15 million people use coastal passenger ferries across Korea. And since 2020, ferries have been designated as part of Korea's public transportation system, but ferry traffic information had long been limited, even though weather conditions often cause cancellations or delays. So PATIS provides real-time ferry schedule, current vessel positions, and estimated time of arrivals for all coastal routes in Korea. So you can check the ship's location on a map and on the route diagram in the bottom. And you can check weather conditions and ticketing links. So this service has been integrated with big private map service company named Naver and Kakao in Korea. So most of Korean people use their navigational services, so travelers can easily find routes from the mainland all the way to the island, with all kinds of transportation connected, from buses, subways, and trains, and even to ferries. And this service predicts accident risks up to 3 days in advance based on weather forecasts, traffic, and past accident data. So this graph shows the changes of risk levels of the specific area as time goes on with a 3-hour interval. And we have improved our AI model step by step. starting from Bayesian neural networks, moving to MLP, which is multiplayer programming, and now we use EBM, which is explainable boosting machine. Then the area is divided into grid like this to visualize and display the predictive accident risk levels. So each area has different weather and fishing patterns and traffic density. So this system helps identify which regions may be risky in the near future. And this service is similar to the accident risk model, but it predicts future congestion level for each region. And it uses vessel position transmitter data combined with vessel size and weather forecasts to estimate congestion over the next 3 days. So this is the sample results of our model, and the left side here is the shows normal condition, weather condition, and the right side shows a bad weather storm. So using the AI model, which is trained with past traffic data, we simulated how traffic changes under these two conditions. So as time goes on, the storm approaches on the right side around Incheon and Busan port area. You can see offshore traffic drops while port congestion increases as vessels move into the ports to avoid the storm. So now let me introduce My Ship service. This service performs as a one-stop platform where seafarers and vessel owners can view all information about their ships at a glance. So it shows, number one, it shows the basic information about their ships and vessel together with technical specifications such as crew capacity, main and auxiliary engines, and other installed equipment. And here, in the ship survey history section, users can check the most recent survey date, the type of survey, and as well as the next scheduled survey. So when the next survey date is approaching, then the system sends a push notification to remind the users. And number 3, it also provides the vessel's accident history. And 4, we provide 2 different safety ratings. One rating measure is traffic safety based on the frequency and severity of accidents, and the other, bottom here, the other shows operational safety, which considers the distance and hours of operation and how often the ship operates in high-risk areas. So these 2 indicators help owners easily understand the overall safety level of their vessels. 안 넘어가네. 됐다. 네. The trajectory history is another key feature. It displays the past trajectory records of each vessel, including locations, time, speeds, and routes. So ship owners can use this data to plan future operation or to improve in-house safety training. And finally, number 6, the system provides a real-time vessel monitoring service. So users can track the live positions of their vessel anytime. This is especially useful for companies that own multiple ships. Even from shore, they can monitor all their vessels so that they can respond quickly in case of emergencies and check if any of their ships have entered danger zones, like where weather warnings or navigation alerts are issued. So in short, My Ship service provides vessel owners and seafarers a practical safety management tool, enabling them to take a proactive role in managing their own safety. So here's future direction. So as we move forward, AI is essential these days, and the universe of AI is huge, from robotics and computer vision to machine learning, neural networks, deep learning, and now here, generative AI. So far, Kumsa's AI applications have focused on more like clustering, fuzzy logic, MLP, BNN, which are more traditional forms of AI. But now generative AI is opening new possibilities. So especially in language-related tasks like summarizing, writing, or translating, etc. So these tools are already improving our work efficiency. But generative AI also comes with challenges, such as hallucinations, security, reliability, and cost. Still, one thing is clear, from the viewpoint of data scientist of myself, I think data is the foundation of all AIs. So let's say that the data is the ingredient and the cooking is analyzing and the cuisine is a service. Then in the past, the specialists like us cooked data into service. Now AI lets everyone create their own cuisine with a very convenient tool named AI. So in this sense, the most important thing is still high-quality domain-specific data. So Kumsa is continuously developing new AI applications with our data. So for example, users could simply ask in natural language that show me the vessel traffic flow around Korean waters. Then we can instantly see the visualized results without needing any specialized GIS or data science knowledge. In another case, we could simply ask, show all coastal passenger ferry routes in Korea, and the AI system will draw them. And then we can even say that overlay accident history on those routes, then I imagine that AI will combine them automatically. So this is the kind of interactive AI-powered data service that we are building for the future. So in conclusion, AI and data together are transforming maritime safety management. And at Kumsa, we are working to make our oceans safer, smarter, and more connected. That concludes my presentation. Thank you.
To introduce about MTIS and POPTIS mandated program, which is developed from Kumsa, I think it is really critical to all of seamen. And then our next order, now that all three presentations of the session 1 have been completed. Next, we will have a Q&A session and discussion on future cooperation, moderated by Mr. Chung Jung Choi, Principal Researcher at Kumsa. I'd like to invite Mr. Choi and our three speakers to come up to the stage.
I am Chung Jung Choi from the Korea Maritime Transportation Safety Authority, and it's my great honor to serve as chair of Session 1. discussion on the way forward for future cooperation. First, let me express my sincere appreciation to the distinguished speakers of Session 1. And today's session has focused on the safety for small and medium-sized ship vessels, delivering meaningful presentations on digital technologies and innovation about data-driven management. First, Ms. Marianne Pastrana of Interferry introduced sustainable freight safety operation cases promoted by Interferry and FastCat. In particular, she highlighted cooperation between industry and international organizations to promote safety, standardization, technological innovation, and support for developing countries. In the Philippines, FastCat has applied digital safety management systems and eco-friendly safety and sustainability. I think her message, safety begins not from policy, but from the will to protect one another, reminded us that true safety starts with a human-centered culture rather than from technologies. Our second speaker, the Professor Zigor Riondo from the University of the Basque Country, presented how to improve safety and efficiency of fishing vessels through AI-based CBM, condition-based maintenance. By shifting from reactive maintenance to predictive, data-driven management, we can prevent accidents, save fuel, and improve efficiency in operation. Like he emphasized, digitalization is not an option, but a must. And he showed us that AI should complement rather than replace for human experience. Finally, Dr. Yuna No from COMSA shared the institution's big data platform, AMTIS, and AI-based maritime safety management innovations. By integrating AI's weather, accident, inspection, and other data, COMSA developed a real-time risk prediction system and the MyShip service, allowing ship owners to monitor their own ship status. This demonstrates a move toward accident prevention centered and sustainable maritime safety management, not just simple technologies. In summary, all these presentations clearly identified the importance of digital transformation in ensuring safer operation of small and medium-sized vessels. We will now open the floor for questions. If you would like to ask questions, please raise your hand, and a microphone will be brought to you. Please. No question? Well,
I have a question.
yes, please go ahead, Marianne.
Okay, so since no one's asking, may I ask a question to Dr. No? They say Doc Yuna or Doc No. So I was quite amazed by your presentation about how advanced your data management is, and you are making it available to ship owners, operators. So my first question is it available for free to ship operators? Who populates the data? and how real time is the data? Like how often do you populate it, and how often can they access that? Because in being data driven, that is one discussion I had with my flag state yesterday, and I was saying, okay, so where are we with regards to not being fragmented and not having silos with our data in the Philippines, so that Marina knows it, Philippine Coast Guard would know it, ship operators would know it, auditors would know it, and I think that is what you are doing. So that's my long question, Dr. Yuna.
Okay. Well, in conclusion, it's free. It's free for everybody. Some services are for to the public, and some services are for the vessel owners or seafarers. They need to log in, actually, because they have private information, like such as vessel position data. So that's very private data. So they need to log in, but it's for free for everyone. And currently, we operate this system for about less than 2 years now. So we have building the platform for 3 years, and now we operate it less than 2 years. But almost 30% of the vessels are utilize this service. So at any time, so they can use it at any time, because the service is internet-based system, so they can just to log in, and then they can utilize the service. And the second question, what was that?
Because I think for the Philippines, we're now starting to populate our database. Just started by getting everybody in the workshop and asking in a voluntary status in filling it up. Did you have to undergo that? And was there any form of resistance from ship operators because of data privacy, or maybe the economic side, afraid of not declaring everything and stuff like that? Yeah.
Well, data privacy is very hot issue these days, so we have to be careful handling those data. And the more difficulties during the building this platform was that actually when we try to connect all the data to make an integrated platform, because even though we have a statement in the law, it needs a common understanding between all the organization in maritime sector. So it was very difficult to having a common sense in data sharing. So that was difficult.
But you did it.
Yes, it took a long time.
And it's now 2 years old. It's something I think we should learn from Philippines. Hello, my flag state's here. Please listen. How can we do this? And for our friends in Thailand, Indonesia, we were discussing about this yesterday. So I hope we learn from you. Thank you. That was amazing. Thank you, sir.
Thank you. Is there any question from the floor? Please go ahead.
Yes, my name is Young-Sik Kim from Korea Research Institute of Ships and Ocean Engineering. I have a question for Professor Uriondo. Can you suggest what is the minimum census set for using your artificial neural network system to estimate the health of the ship, the fishing boat engine? And then you mentioned about the cost effect for the fishery industry. What do you think? What is the minimum cost rate for using those systems commercially in the ship boats industry?
Okay. Here, can you hear me? Okay, sorry. I mean, the question is clear. It's easy. The answer is not so easy. Why? Depends on the size of engine. I mean, The minimum I would say is just maybe 14, 15 or so temperature sensors, 2, 3 pressure sensors. Why? One exhaust cylinder, 4 cylinder, 6 cylinder, 6. Previous turbocharger, maybe 2, 1, 8. Outer turbocharger, 9. Air temperature, 10. Okay, we can go increasing, but what happens if the engine is really small? If it comes, for example, from the industrial sector, let's say it's quite common to have industrial engine marinized, then maybe you are not going to find even room for so many sensors because they are more compact. Then you have to reduce, okay, before turbocharger we can. So this is what I mean, that the strategy has to be which engine I have, which is the minimum I can implement and will be better than anything. So nowadays, if it has an electronic control unit, there are already many sensors implemented on it. In such case, you don't even need to install them. Just have to communicate maybe a CAN or another digital protocol, so it's even easier. So that's why, unfortunately, it has to be done case by case. But I will go minimum for 5 with, I don't know, 2,000–3,000 euros, and also the cost depends, because regarding maritime industry, the costs are very different in Asia and in Europe. And a minimum, okay, will be something like this, okay? From a small to medium, there is not a progression. Sometimes there is just a leap. A medium engine, especially if it is classified, will have already a big set of sensors, so you don't need to expend money on it. You don't need to invest. You just have to deal with the data that we are already generating. Because especially with medium size, and if they are classified, they are already quite well monitored. So there's no need to invest in the sensoring. It's more the part of recording it, sending it, and dealing with it. It's very interesting that Dr. No said that they have in real time all the ferries, but also would be good to know if there is an alarm, there is a stop signal in a ferry, is this signal tripped immediately to the system? Or is someone that has to inform, no, the ferry is stopped? This is my question also. I mean, when we talk about digitalization, how we can put everything together, because at the end, IoT, and maybe the vessel is not integrated, and small things are already integrated. If in a small vessel, the trip is immediately sent to some authorities that we have a stop in the engine, maybe it's nothing. Sometimes just go back, ask to the vessel, what has happened? Nothing. The sensor fault, but the engine is correct. Okay. But minimum, I don't know, depend. 2,000, from 3,000, for me, less than 3,000 euro will be impossible to start thinking about it.
Yes. Can I have a follow-up question, Professor? So you're putting sensors, on fishermen boat, and what kind of competency must they have, and training that you must do and give fisher folks in order to appreciate digitalization and the impact that it will do for them?
I mean, some pictures that I show, especially the one of this digital panel, okay, that was in a fishing vessel. I would say medium size, because the engine is 1,000 kilowatt. In such case, in fact, it is not needed to, let's say, make anything in the engine. The work is done. They have already the hardware on board. The only thing extra to be done is to put an Ethernet cable to something that transmits the data shore. So basically, the hardware, most of it is there. So we need to take the next step. Okay. For training for them, basically, most of cases, they don't need special training for that. No, because they have to do what they have done until now. The only thing is that someone or something will tell them, look, in this cylinder, maybe something is happening. I mean, in the different steps of AI that we have seen, we are still in the very beginning. So we are not talking about generative, no. We are just in the very beginning. We are talking still, or yet we are talking yet that we have to transmit data and we make a strong data sets. We are just in the beginning, okay? Then we have to implement it, keep it running, probably for years, because there will be many false negatives many times. And false negative means that you are not with a reliable system and the people will not trust on it. Okay, so then we are going to need years this system working. In this case, association like CONSAM might be very interesting because maybe it could be the place where the servers and the service could be provided. In many cases, especially for small fishing boats, that could be 1, 2 crew members, totally necessary for free because they cannot afford it. So.
Well, thank you for your response. And now we will take a question from our online participants joining via YouTube live stream and QR submission. Okay, I have a list for the question, and I will choose one. For this question goes to Zigor Riondo, and the question is that how does condition-based maintenance differ from traditional preventive maintenance in terms of safety and efficiency?
Okay, first we must understand first many manuals and instructions are provided to the people that take care of maintenance. If you get a manual for an engine maker, there you will have that every X thousand running hours, 10, 12, so many, disassemble the engine, open up everything. And many times you can see that they have a small remark, but depending on engine condition. So basically they are covering their backs, themselves, and go to the safer side. So let in the owner or in the operator side to extend the maintenance intervals. And the question is, why extend the maintenance intervals if I don't know how the engine is? I think that the CBN could take a part on this. Instead of maybe repairing or exchanging parts every X thousand running hours, no, maybe increase a little this, and some parts extend the life, but maybe others, we have to reduce the life. So in this case, most of the time extending the life because you know better how the engine is running. You have better insights to what is happening in the engine. So then you can try to extend the life in some parts, but also preventing in the small percentage of possibility of failure, reducing this percentage because you know better what is happening on the engine, and these abnormal conditions you are going to detect earlier in this way, okay? And also in the case of fishermen, the first thing is one thing that we must know is the fuel. I mean, when we monitor, we are going to be able to know which is the fuel consumption of the engine. Just this, if you know the fishermen, this in their mentality makes them manage the fuel consumption, so manage the throttle. And this, in my experience, can bring reduction from 10 to 20% of fuel consumption easily, just knowing, because the vessel energy consumption is cubic. So it means that at the end, just a small speed means a lot of fuel. 10%, 10% speed, 25, 30% fuel. So just a small reduction. When they notice it, they just reduce the throttle.
Okay, thank you very much for your responses. And due to time constraints, we will now conclude the Q&A session. And before closing, I would like to invite each of our speakers to share briefly their reflections on this session and your suggestions for future cooperation in enhancing small and medium-sized vessels' safety. Please,
Yeah, so thank you very much for having me here, Komsa. Thank you for your hospitality, and I'm happy to meet everyone and talk to everyone and learn a lot. I have learned a lot. May I invite the other countries who have not yet joined Interferry? Please join us in Interferry. We're one happy family caring for the safety and international cooperation, technical cooperation, and we hold a seat, consultative seat in the IMO, thereby influencing policy making. So that's for Interferry. And for the rest of you, may I invite you also, if you have not gone to the Philippines, please come visit us. Come visit our 7,641 islands and make sure you ride a fast cat. Thank you.
I also enjoyed all the presentations, and then I learned a lot as well. And I think all three presentations converge on a common point that the real value of digitalization lies in turning data into safer decisions, and that is what true smart safety means. That's what I thought. And thank you for being here today.
Okay, for my side, it has been quite interesting to come here to talk, also to see in some areas what is being done in Asia, because in Europe we have quite a close research environment with all the countries, but maybe not so open to other areas. So for me it has been quite interesting to come here and to see especially what is being done, some things. And thank you for inviting me.
Yes, good. I would like to thank all three speakers for your insightful and forward-looking remarks and practical suggestions. Today's discussion made it clear that innovation and collaboration and data-driven action are key to advancing the safety of small and medium-sized vessels. And the future of maritime safety as a whole. In particular, with many participants from developing countries and international organizations, this session has become a meaningful platform for sharing experiences and knowledge and promoting cooperation across borders. I sincerely hope that today's dialogue will serve as a starting point for continuous partnership and mutual learning among our countries. Thank you for your kind attention. This concludes session 1, discussion on the way forward for future cooperation. I now hand the floor back to MC Myung. Thank you.
Thank you very much. Please give a big hand to today's moderator, Mr. Choi, and our three speakers for their excellent discussion. And then this concludes the first session of the forum. We hope the first session was informative and valuable for everyone.
So, friends, I hope you liked the conference that happened in Korea. This forum affirms our direction, integrating data-driven maintenance, smart safety measures across branches, and aligning investment in green technologies with financial tracking and sustainability commitments. Again, together, let us sail to a safer and greener shipping. Anytime Maritime.
Anytime Maritime. Anytime Maritime.